Next, we are going to find the domain of the function. That would be easier to know the type of the function and then think about the restriction of that type of the function. For example, if we know that the function is the polynomial function, there is no restriction. Therefore, the domain would be the set of all real numbers, or we can write it in the interval form as the open parenthesis, negative infinity, comma, infinity, and then close parenthesis. In the case that the function is the rational function, key term the ratio, that means you have the polynomial divided by another polynomial. For the rational function, we know that we cannot divide any function with the quantity 0. The restriction of this would be from the denominator. So we're gonna set up by looking at the inequality that the denominator cannot be 0 and then work from there. Another case, if we have the radical function or the root function, depends on the index of the root or the n root here. So going to be two cases. If n is an odd number, for example, the third root, the fifth root, the seventh root, and so forth. That means whatever the number that raised to the third power, the fifth power, or the seventh power would be the quantity under the radical. There is no restriction for that because when you multiply the negative number 3 times, the sign still remain negative. So for the n as an odd number or the index as an odd number, there is no restriction. The domain would be the set of all real numbers. In the case that n is an even number, for example, the square root, the fourth root, the sixth root, and so forth, there is a restriction because when you think about the negative number, multiply itself twice, the negative side will become positive side, or the product will be positive. Therefore, the restriction for the even index would be non-negative number. That means we're gonna look at the radicand, which is the expression under the root. Set it up as the inequality, like greater than 0, and then we're gonna work from there to find out would be the possible x of what would be the possible x that satisfy the restriction of this radical function with the even index. So let's get started. The first example, the function for part A here, the function is 4x to the third. We know that this is the polynomial. The polynomial has no restriction. Therefore, the domain use the notation D with the subscript F because the notation F there. So df, the domain of the function F would be the set of all real numbers. Or you can write as this notation as a shortcut. The second one, or part B, the function f of x equals 3 divided by the quantity x to the third plus 4x to the second minus 5x. This is the rational function because you have the quantity divided by another quantity. The restriction of this is the denominator cannot be 0. If the denominator cannot be 0, we're going to start working on setting up the inequality for the denominator. X to the third plus 4x to the second minus 5x cannot be 0. And then we are going to solve this polynomial inequality. As you see, we have x to the third, x squared, and x term for and x within the terms in the expression. We're gonna factor the x out, and then we have x multiplied by x squared plus 4x minus 5 not equal to 0. We can factor further for the 3 terms in the parentheses. X squared means you have the x multiplied by x 5. That would be from the number 5 and 1. the negative side represent like the product of these two would be from one positive term and the other negative term. But the middle number here has the positive inside. So that means the greater value has the same sign as the result. So we're gonna have plus sign here, minus sign here, not equal to 0. And you can double check by multiply it back, like the inner would be 5x, the outer would be negative 1x, the result would be positive 4x. Check. From this, we can say that each one of them cannot be 0. That result, the x cannot be 0. X plus 5 cannot be 0, and x minus 1 cannot be 0. Do it a little bit more. So x cannot be negative 5, x cannot be positive 1, and x cannot be 0. Write it in the better form. So we have the domain of this function in the set builder notation form as x cannot be 0, negative 5, and positive 1. Next example, we have the f of x equals square root of x squared minus 5x plus 6. So this is the radical function with the index 2, because this is the square root. Index 2, which is an even number. The even number, the restriction is the radicand cannot be negative number. Cannot be negative, so we can set it up as x squared minus 5x plus 6 must be greater than or equal to 0. We have polynomial, but inequality. So we're gonna factor again. We have x squared, that is from x times x, 6. The 6 would be from the product of 2 and 3 to get the sum as 5 or positive 5 there, a negative 5 there, but the sign negative, that means both 2 and 3 would be negative inside, greater than or equal to 0. We got two critical numbers, the number 2 and the number 3. How do you put them together as a domain to satisfy this restriction? Draw the real number line. Locate the two critical numbers, 2 and 3. Check the sign. If you pick the number greater than 3, so I'm going to put the number, put the factor here, x minus 2 times x minus 3. If you pick the number greater than 3, for example, 4 minus 2 is 2, 4 minus 3 is 1. So the product gonna be positive inside. You pick the number between 2 and 3. Greater than 2, the first product gonna be positive inside, and the next gonna be negative. The product will be negative, and this is positive. Another way that easier to help you identify, you put it over here like x minus 2 and x minus 3. Let's change the color to help you out in the easier way. Any number greater than 2, this is going to be plus sign, less than 2 means negative sign. For x minus 3, anything greater than 3 going to give you positive, but less than 3 be negative. So you multiply these two signs to get the sign of the result. Now, how do we put together as the answer or as the domain of this function? Our goal is to get the set of the numbers that give the product as positive inside or greater than or equal to 0. So we're gonna pick up the left interval and the right end interval, put in the form as the domain of this function as a set of x such that x is less than or equal to 2 or x is greater than or equal to 3. or in the interval form would be from negative infinity to positive 2, including union 3, including 3, all the way to positive infinity. And the next case, we have the cube root of 1 minus x squared. As you notice, the index is 3. I'm going to put a note. This is the radical function, but n equals 3, which is an odd number. If it is an odd number, there's no restriction. That means you can use any number, positive, negative, or 0 within the cube root. If it is if there is no restriction, we can say that domain of this function is the set of all real numbers, or put it in the interval form as from negative infinity to positive infinity. And the last one, the function is x plus 2 divided by the square root of 9 minus x squared. This is the combination of the rational and the radical function. So we have to look at one restriction at a time. For the rational, that means the denominator cannot be 0. For the radical, with n equals 2 or an even index. So we're going to have to set up as the radicand, or 9 minus x squared, has to be greater than or equal to 0, or the radicand is non-negative. So we're going to intersect these two restrictions as a common restriction for the domain of the product function f. So one at a time. For the rational restriction, the denominator cannot be 0. So we take the whole thing. The square root of 9 minus x squared cannot be 0, or 9 minus x squared cannot be 0. Now, we can do this as factoring, or you can do it in a quick way, but have to be careful about the sign. So I'm going to rewrite it as x squared minus 9 not equal to 0 because it's no change. And then factor it completely to be x minus 3 times x plus 3 not equal to 0. Or we can get x cannot be positive 3 and negative 3. So this will be from the first restriction. And the next restriction, or the radical, radical function form, sorry. So then the radicand, which is expression 9 minus x squared, greater than or equal to 0. We use a similar technique by writing in a convenient way, x squared minus 9 less than or equal to 0. Factor completely like what we did before to get x minus 3 times x plus 3. Strictly less than 0. And use the similar technique that what we did in the previous example. Look at the critical number, because this will be x equals 3, this will be x equals negative 3. Line them up in order. And I'm going to use the similar technique like before. So x minus 3 factor and x plus 3 factor, and then see what's going on. For the value that greater than 3, this is going to give us positive sign. And then less than 3, going to give negative sign for this factor. And for the x plus 3, any number that greater than negative 3 gonna give us positive sign for this factor, but less than 0 for the number that less than negative 3. Since this is a product, so we just multiply these two sides together to get the result of the sign of the product as plus sign for the right end. The middle one, the product of these two sides will become negative inside. The product of the left end gonna be positive inside. So this, the sign on the top would be the sign of the product x minus 3 times x plus 3. So what are we going to take? We are going to take the one that is less than or equal to 0. Which one? The middle one. That means from this restriction, from the radical restriction, we are going to take the middle one, which is x greater than -3, less than or equal to +3. And now we're going to combine, because we are going to combine these two restrictions together. Therefore, for x not equal to 3, and I put in the real number line, the first one not equal to, so gonna empty circle, anything on the left, on the right, skip -3 and +3. And then for this restriction, I'm using different color. Let's see. We're gonna take the one in the middle. Include for the intersection, that means the one in common. For the one in common, we're gonna look at the one that overlapping. Therefore, the domain of this function or df would be the interval from -3 to +3, not including the two ends. Or you can write it as a set builder notation as x, such that x is strictly greater than -3, strictly less than +3 as a result.